part 2. And we're going to kind of work through this together, if that's all right with y'all, instead of y'all having it to do and turn in. If there's not any problems with that. H31, integration by substitution. Thank you. It says part 2 to it there, okay? Before we jump into that, did you have any questions about anything that you missed in the 5 problems that I graded for you? Careless mistakes are what I saw more than anything there. Terry, you weren't here when we talked about integration by substitution. Okay, so we'll try to get you up to speed today on that. So let's begin by looking at this problem in H31, integration by substitution. And somebody tell us, what do we mean integration by substitution?
We're plugging in u and du to try to make it easier to integrate to like
That's right. We're going to use some type of substitution and change the variables in there. Now, how do we look at it and know that we need to do something like that? How can we look at this problem and say, I've got to do integration by substitution. Why can't we just integrate that using the power rule? Huh? Why can't we integrate it just by raising the thing to a higher power and dividing by that power? Finding the antiderivative. How do we know when we look at something? I guess that may be the best.
Inner function.
We're looking for inner functions and outer functions. So anytime you've got something that's inner and outer, or anytime you've got something that's being multiplied or divided, or a square root, any of those things are going to lead you to believe that you probably need to do some type of u/du substitution. Well, Nick, what did we say we normally look at for the u? What's inside of something, inside of parentheses, inside of square root. Several of you got it. I was very impressed on one of them on homework, whatever's in the denominator of the fraction. So something that's being grouped together. So in this case, we would start off by let u equal x squared plus 1. Okay? Now, what's the next step after that?
du.
Find du. How do we find du?
Take the derivative.
Take the derivative of u that we wrote down. Remember, I told you, you don't want to look back at your integral to find your du. You want to find your du by looking at u. So du is 2x dx. And we talked about algebraically why we put the dx over there. We're just thinking of it as algebra. Now, after we do that, we're going to look and see. What can we do? Well, we've got an x squared plus 1, and that'll go in there. But as Jonas noticed, we don't have 2x dx over there in our integral, do we? So we've got x dx. So if we take this and divide it by 2, now we get 1/2 du equals x dx. Now we've got x dx over there. So now we should be able to substitute in. So we're going to substitute in over here for those two things. So let's rewrite our integral now. Instead of x's, we're going to have u's in there, okay? So instead of x squared plus 1, I'm going to put u. It's still being raised to the 3rd power because x squared plus 1 was being raised to the 3rd power. So I'm just replacing this thing with u and still cubing it. What can I replace x dx with? With 1/2 du. 1/2 du. And then we integrate like we always have. Okay? Now notice I didn't put the limits of integration on there, and I'm going to explain why in just a second. If I'm going to integrate this, we haven't done it much, but you're going to find that it's very useful to go ahead and move the constants outside of the integral. So I move that 1/2 out. It's normally going to be easier to integrate. So now it's basic integration that we can use the power rule for. And what's the integral, Claire Daniel, of u cubed?
1/4.
Okay, so I've got this 1/2 and this 1/4 and u to the 4th. Okay? And now, what were we doing yesterday from that point? Plus c. Thank you. Do we leave our answer like that? No.
Simplify.
We go back to put in, we had x's in it to begin with, so we would go back and make this 1/8 x squared plus 1 to the 4th plus c. And that's what we did the day before yesterday. We integrated everything that way, so now we've got an integration. But what's slightly different about this problem? We've got 0 and 1. We've got limits of integration. When we have limits of integration, what kind of answer do we normally get? A number. And that number represents the what? Area under a curve, okay? So now, what we have to do is we have to remember once we get to this point, we now have to evaluate this thing at 0 and 1. Okay? That's the only thing we're adding to this. We're going to add to that and say 1/8 1 squared plus 1 minus 1/8 0 squared plus 1. And it's very important. Y'all have gotten into the habit, at least in your writing, of not writing down the second one when it's 0 because it's always been 0. It's very seldom going to be 0 from here on out. Yes, sir?
Does it still need to be the 4th power?
It does need to be to the 4th power. Thank you. Forgot about that. Good question. What happens to plus c?
It just
You
cancels
subtract
out.
it.
Cancels out.
We could write plus c, couldn't we? But remember, if we write plus c in here, then we're going to wind up subtracting it off so it doesn't make any difference. So the c is not going to matter. So if we do this, we have 2 to the 4th is 16 divided by 8 is 2 minus 1 to the 4th is 1 times 1/8. 2 minus an 8, we get 15 eighths, not sixths. 15 eighths for an answer. Okay? Is that complicated? Now, let me tell you the mistake you're going to make. Or does anybody have a why question right now? Okay, then I have a why question. Why didn't we just evaluate it right here when it was 1/8 u to the 4th? Wouldn't it have been a whole lot easier? Why? Why? I got a 0 and 1 to plug in. I want a number in here. Why can't I just plug in the 0 and 1 right there? Thank you, thank you, thank you, thank you, thank you. Yes. Subtle point here, okay? Common mistake that students try to do is once they get to this point, once they get to 1/8 u to the 4th, they say, oh, I got numbers, limits of integration, I'll plug in and I'll get my answer out. Okay? Big mistake. Because this 0 and this 1 are talking about we want to integrate from when x is 0 until x is 1. Okay? Well, if we plug it in here, we're not putting 0 and 1 in for x. We would be putting them in for u. So the easiest thing to me, or what I've always taught, is you go ahead and put in your x squared plus 1 and then integrate. You could say when x equals 1, u equals 2. When x equals 0, u equals 1. Y'all see where I got those from? Because if I put 0 in here, 0 squared plus 1 is 1. And when I put 1 in, 1 squared plus 1 is 2. So I should get the same number if I evaluate 1/8 u to the 4th at 1 and 2. Because when x is 0 and 1, u is 1 and 2. And if you evaluate that, I think you'll find out that you get 15 eighths again. All right? Don't switch back and forth between these two, okay? Either do it the way I did it in green every time, or once you've integrated, find out what your u's are and do this. Don't switch back and forth because you're guaranteed to mix up. Personal opinion, I would do the green every time. But you could do the red if you so chose to. All right. I'm going to give you about 2 minutes to see if you can come up with a solution to that problem right there. Go. I see this written down on a lot of papers. And then I see Paul's. What's the problem? Why is everybody paused at that point? It's a good place to pause. I mean, it's not there.
Yeah.
Well, can't I do this? I could do this and get closer, couldn't I?
Mm-hmm.
But then I still got an X left up there. Can we do that? All right, if we multiply both sides of du by x, then we're integrating, we've got x's and du's together. And how do we integrate with x's and du's in that? That's up the line somewhere in Cal 2, Cal 3, Cal 4, somewhere else. So we can't integrate. We've got to have one variable in here. Only one variable. Yes, ma'am? Excellent. Excellent. We can come down here and take this one and say if u equals 2x minus 1, well, u plus 1 equals 2x. And u plus 1 divided by 2 equals x. All right? So now let's see if we can plug in and figure out what to do from there. Well, for x, I'm going to put u plus 1 over 2. For the 2x minus 1, I'm going to put u, and it's got a square root, and it's in the bottom. So what's the easy way to write that? Yep. U to the negative 1/2. And in place of the dx, I can put,
Bless you.
bless you, a half du. Now, please do not write 1 and 5 on there for limits of integration. Why not?
Why not? Because you gotta plug them in back to the original function.
Right, 1 and 5 are the limits of integration when we're integrating with respect to x. We aren't integrating with respect to x down here, so don't put the 1 and 5 there. Legally and mathematically, that's the reason you don't write the 1 and 5 there. Practically, you don't write the 1 and 5 there because if you do, you're going to get lost down here in about 5 minutes and see, I've got this thing integrated now, I can put 5 in for you and I've got my answer, I put 1 in for you and I've got my answer and you've missed it again. So don't put the limits of integration. Well, what on earth, well, Daniel, you led us down this road, where do we go from here? Very good. We can distribute the u to the 1/2 to the u plus 1, and we can get u to the positive 1/2 plus u to the negative 1/2, still over 2, times 1/2 du. So what do you want to do now? Anyone? Claire's got us to here. Someone else tell us what you want to do now. Okay. Jerry says, I'm going to move 1 over 4 out of the integration. Explain to us where the 1 over 4 came from.
It's 1 over 2 times 1 over 2.
Right. This box right here is the same as 1/2 times u to the 1/2 plus u to the negative 1/2. So then he's going to take this 1/2 and this 1/2 and bring them outside the integral and make it 1/4 the integral of u to the 1/2 plus u to the negative 1/2 du. All right, so now we should be able to integrate that. If we integrate u to the 1/2, we get u to the 3/2. So we get 2/3 u to the 3/2 plus, that'll be u to the 1/2, 2u to the 1/2. Remember, we've got a 1/4 out in front of all of that. And are we ready to evaluate it at 1 and 5 now? What do we need to do then? Plug in the 2x minus 1. Now understand, you can multiply this 1/4 through. I'm not going to yet because I'm hoping life's going to be easier if I don't do that. 2x minus 1 to the 3 halves plus 2 times 2x minus 1 to the 1 half. And we're evaluating it at 1 and 5. Is that right? Y'all okay with that? So now we're going to evaluate it at the 1 and the 5. 2 times 5 is 10 minus 1 is 9. So the square root of 9 is 3. 3 cubed is 27. And 2/3 of 27 is 18. So we've got a 1/4 way out here in front of all. Plus 2x minus 1 is still 9. The square root of 9 is 3. 3 times 2 is 6. What happens when we put 1 in here? 2 times 1 is 1 minus 1 is 0. So everything's going to go to 0 back here, isn't it? So, huh?
Or not for the second one.
2 times 1 is 2 minus 1 is... So 0, when I evaluate it at 1, I get 0 plus 0. So I've got 1/4 of 24. Looks like the answer is
But you're not
6.
evaluating at 0, are you?
Oh, no, I'm sorry. When I put 1 in, see, I'm putting the number 1 in and I get the number 0 out here.
No, because you get 2 minus 1, which is 1. Isn't that?
No, thank you, thank you. I said 2 minus 1 was 1. Okay, thank you. All right, let's back up and try that again. 2 times 1 is 2, and 2 minus 1 is 1, and all of that's going to be 1 times 2/3 is 2/3. That's going to be 1 times 2 is 2, so I've got 2/3 plus 2. Sure was a lot easier when I did it my way. All right, so we've got 18 plus 6 minus 2/3 minus 2. I've got 22 minus 2/3. That's 66/3 minus 2/3. That's 64/3, and all of that is times 1/4. 4 go into that 16 times, so I get 16 over 3 for an answer. Do y'all like that better? Or not better, but is that more right? How you feel? Just long? All right, let's see if I can give you one that's not. How do we look at that and know that we've got to do this ugly U and X double substitution here?
Well,
The inside and outside, and our outside's not our derivative, is it? Most of the time, if these two things are the same power, if your inside function and your outside function are to the same power, that's when you're probably going to look at doing a double substitution. So you may just want to file that away. All right, let's look at a couple more. This is a nice one to look at. See what you can do with this one on your own. Again, I'll give you a couple minutes. This includes all this fun trick stuff, so that's always fun to play with, isn't it? Anyone want to state why they think it's best just to pull out the cosine? Or why they think they should pull the cosine and the sine? Because? You're right. Say it. Just read what you got there. Okay. What did you choose for your U? Okay. Claire Looney says she's going to let U be sine X. And if you let U be sine X, then what's du, class? Cosine X dx. So if you do that, then having just the cosine pulled out makes more sense, because now here's my du. There's my du right there. And And then I think it turns into something that's somewhat simple to evaluate. Yes, sir?
When you do the sine 3x. Sine 3x.
Sine cubed x. So-
So
All right, so you're gonna be in,
U cubed.
you're gonna be substituting in now, right? So now when we substitute in for u, you'll have, what will you have here, Nick? There you go, u cubed. Very, very good. So, see if you can finish that off. Now evaluate it,
I
you're
just did it
picking
this
the class.
way, because I figured two.
Yes. You're gonna wind up with the same thing.
Oh, okay.
Yeah, you're gonna wind up with the same thing. Now just evaluate it at your limits and
Oh, yeah, I totally agree with that too.
What's the sine?
I hear you pulling your calculators out, and that's okay, but you've got to be able to do this on a test without a calculating device.
Why do they make you know this junk when you have calculators?
That's the way it is. What,
How do you do the?
It's,
uh,
sine
what's the sine at pi over 2?
1.
1. How do you know that?
Because if you look at,
Halfway up the.
Yeah. I see pi over 2 is straight up in the air. The sine is the second coordinate, so it's 1. Yes, ma'am. Okay, now integrate. How do you integrate u cubed? Don't think of it as multiplying. We are integrating all of this with respect to u. This is just like if you had 2x plus 4, you'd integrate that to x squared plus 4x. Just like, that's what you did on your last, well, you haven't done it, but that's what you're gonna do on your last test.
You said no comment.
All right, so pi over 2 is 1. What is negative pi over 2? Negative 1, because see, it's going to be down at the bottom. If you're looking at it as a unit circle, it's going to be down at the bottom. So we've got 1/4 plus 1/2 minus negative 1 to the 4th plus negative 1 squared. So it's going to be 1/4 plus 1/2 minus 1/4 minus 1/2? Going to be 0? Y'all comfortable with that? What does that mean graphically?
Both at the 0 point.
They're both at the 0 point, meaning what?
Or if they're both at the same
Integrating finds what graphically?
The area.
Area. So the area is 0?
Yeah, the net area.
Get the net area. What? So that means,
It's gone, as far up as it's gone down.
right, however much area you see above the x-axis, you're going to see that exact
Just
amount below.
sine thing.
Yeah, because the sine is cyclical, so you're going to have you're going to have the same amount above and below. So very good, very good. Impressed with your abilities there. Okay. Is that complicated? No. Yeah. Let's go to 3. Okay. Go to this one here. You should be capable of doing this. Looks like it's about slide 5 or 6, something like that. I don't know. I'm a different book than you are. Practice is the most important thing with these things.
No, very close.
Very close to it.
This one's easier.
This one's a lot. Yeah, this one has a x squared.
Yeah. We did one just a moment ago that had 2x down here. Yeah.
point half, do you add them together or do you multiply?
Right now.
If u is x squared plus one, b is gonna be one,
You're trying to make it harder than it actually was.
I'd keep it up there and multiply this after.
Mm-hmm. Yes. Now notice this one doesn't have any limits of integration. So what does that tell you you should see in your answer?
Plus c.
A plus c, okay? Don't forget that. How can I check to be sure I got the right answer? Yes, you should be able to find the derivative of what you started with, of what you have, and you should be able to get back to where we're at now. Okay, so we're going to integrate, well, we don't have a 2x, so we got to do a 1/2. A common mistake that students are going to make is putting, when you getting messed up on all of your coefficients. I'm integrating 1/2 u to the negative 1/2. Because that x squared plus 1's in the denominator, so I'm integrating 1/2 because I put in a 1/2 do plus u. So now I've got a 1/2 times, this is u to the 1/2 divided by 1/2, which means it's times 2. Plus c, those are going to cancel out, so I've got u to the 1/2 plus c, so that's x squared plus 1 to the 1/2 plus c. Any confusion there? All right, we've got some challenges ahead of us with these problems here. So let's talk about 5 before you jump into it. You've got tan squared and you've got sec squared. What do you think your what do you think your u should be here?
Sec squared, tan x.
Sec squared, tan squared? Oh, I got it.
just tan.
Just tan. Why just tan?
Because derivative of
Sec
tan is
squared.
Derivative of tan is sec squared, okay? So, go ahead and solve this. I think you're correct that u is the derivative, that u needs to be tan x there. And remember, when you finish, you should be able to take the derivative, or at least look at it and say, if I took the derivative, I can get back to where I started from. Sure I can see everything, everyone. Okay, the customary way to write it is how I've got it there, tan cubed x over 3. Now, just be sure that when you write it, if you don't like that, if you want to put the cubed on the outside instead, you need to put the tan x in parentheses. Both of those mean the same thing. If you don't put the parentheses and put the cubed on the outside, you're telling me to cube the x. So either write it like this, or write it as tan cubed x over 3. Either one means the same thing. The tan cubed x over 3 is going to be more common. All right, that's not a problem, so we're gonna keep moving on past it. This one's not really a problem, so I don't want to, I want to get to something, this one's a little bit more of a challenge for us. So we're at the one listed as number 21. That's kind of where I want to go to now. Let's see if you can handle that. And I really want you to think about, you're right on your instinct of what U needs to be. And you need to talk with your cohorts a little bit and see if you can come around and figure out how we're going to do the substitution here. Because you're correct with your U, I'm almost positive. Curveball that you couldn't hit. Jeez. When I get my du is negative 2x, bless you. Why is that difficult? Why does that pose a difficulty for some of us? Because in the problem we've got 5x, and it's negative. So how do we turn a negative 2x into a positive 5x?
You divide it by negative 5 over 2 on both.
If we multiply this side by negative 5 halves, if we multiply the right side by negative 5 halves, won't that make it a 5x? Well, if we multiply this side by negative 5, we need to multiply that side, the other side by negative 5 halves. So we say negative 5 halves do equals, here the negative and that cancel, equals 5x dx, and then we can substitute in just fine. That's very challenging to see there. Okay? Let me show you another way to look at that. Alright? Remember, this 5 is a constant term in our original problem. So we could just pull it out in front and know that we've got it, in the end, we're going to have to multiply our answer by 5. Well, if we do that, then du, over here we get du is negative 2x dx. Well, we need it to be x, don't we? So if we need to divide both sides by negative 1/2, and now when we substitute in, we're just substituting in a negative 1/2 for du. But we've already got a 5 on the outside, so when we multiply it, we're going to wind up back to the negative 5/2 anyway. So if pulling the 5 out first makes it easier for you, that's fine. If you can see this, that's very good mathematics. If you can see what we originally did in the red, boom, that works fine as well. And we should be able to simplify it from there. So let's substitute in. We're going to have the integral of negative 5 halves u to the 1/3 du. And if we third, and if we do that, so we've got negative 5 halves, 3/4 u to the 4/3 plus c, negative 15/8. One minus x squared to the 4/3. Plus it. Easy to forget. So, do these seem challenging to you?
More tedious.
More tedious. I feel like y'all are doing a very good job algebraically with these, so I don't want to just continue wasting our time. We've done one similar to that. We're not going to take our time. We've done one similar to that, not gonna waste our time. Yeah, that's an indication that we need to do this, I would say. If you look at it and say, ew, we need to look at this problem.
Yeah, it's kind of nasty.
This looks nasty because there's fractions in this nasty thing, okay? Hold on, let me see for a second. Can we actually do this? Let me think for a second. Yes, no, yes, yes, we can do it. Yes, yes, we can do it. Sorry.
How do you find a derivative of e to the negative 4?
It's a good question. How do you find the derivative of t to the negative 1? Anyone want to elaborate on how they're finding the derivative of t to the negative 1? Negative t. Negative 1, t to the negative 2. Just use your power rule. The derivative of x cubed is 3x squared. You're trying to integrate it. We'll learn to integrate it on Tuesday, okay?
Doesn't fill with confidence.
We'll learn to integrate 1 over t on Tuesday. It's a very simple rule. Very simple.
Yes, you can.
So when I substitute in, I'm substituting u negative du. I'm going to integrate u negative u. Is that what everybody got? Oh, q. Jeez, I can't remember what it says. Okay, u cubed. That looks better. Even better. And boy, that's
There's triples.
u to the fourth over 4 with a negative sign in front. Parentheses 1 plus 1 over t all to the fourth over the number 4 plus 6. Are we okay? All right. Really though, even though you said ooh, it becomes really more tedious than anything else. All right. Now, look at that for a while. Look at that for a while. See what you think we ought to do. I want to hear some ideas bouncing around the room, either to your cohorts or to the group as a whole. Bounce some ideas.
You have to break it up.
Can't we just do the power rule? We've got a quotient there. Maybe you can, but you can't do it just the power rule, just looking at it. Claire, you want to elaborate? Okay, that's what you were trying to say? We're going to bring this up and make it x to the negative 1/2, and then distribute through, and then integrate. Okay? That sounds like a grand idea. Anytime you have a monomial on the bottom, what's a monomial? A term. You don't have any pluses and minuses. Anytime you've got a monomial on the bottom, you should bring it up and distribute. It's just going to make life so much easier if you do that. So, bring it up, distribute. I'm confident y'all can handle that. We're not going to waste any more time. Wow. See what you can do there. See what you can do there. Any ideas you want to share? Yes. We're just going to distribute through, you mean says. Why don't we want to do a UDU?
That's more trouble than it's worth.
Can we? Good, is a good question.
No, I don't know.
Yeah, if you said U was this thing on the inside,
I don't think you
DU's not gonna be T squared, is it?
It's gonna be t to the negative 2.
Yeah. If you do U is T squared, that's not gonna be it. So you don't have a U DU you can easily do. So distributing and then integrating without substitution is gonna be the easy way to do that. So finish that off just to kind of refresh our minds on that.
That's right.
I don't know what you're doing the old way the entire time.
We've been doing a step before the old way, you're right. It's, you get kind of confused there after a while. All right. Boy, that was not too challenging, I'm glad to see. Now, it says solve the Diffie Q. What does that really mean? What do you think that means?
That means,
Do what we were doing with plus c.
Yeah, integrate. That's just a different way of saying integrate this, okay? So we're going to integrate. All we need, what is dy over dx? That's a derivative. We need to find y. So this is really just saying integrate this puppy. How are we going to integrate 4x plus 4x over square root of 16 minus x squared?
it's 4x times 1 plus.
What's it? Say that again? You lost it.
No.
You got a 1 plus in there.
Okay, it's 4x times 1 plus 16 minus 16 minus x squared to the negative 1 over 2 now.
All right, so what Jerry did, Jerry just factored this out and said, I got 4x times 1 plus 16 minus x squared to the negative 1/2. And yes, you're right that you got that. So how are we going to integrate that?
Have to do that?
I don't know. How are we going to integrate that? You got to tell me. What are you going to let u be if you're in there?
16 minus x squared.
Yes. Why would you say 16 minus x squared?
At least we'll be on the right power.
Yeah, at least we'll get to the right power out here. Yes, this is a way to do it. Let me show you something that might seem a little bit easier for you. There's nothing wrong with this, okay? But I could also write this as the integral of 4x plus the integral of 4x over the square root of 16 minus x squared. Okay? I could do that, and I'm going to get to the same answer. This, you look at this, well, gosh, that means integrating twice, but what's the integral of 4x? I bet you can look at that and know what it's going to be, 2x squared. So you could do it like, you could simplify, or excuse me, you could expand the integral to begin with and get there, or you could factor out the 4x down here. Either way should get you to the same answer there. So I'll encourage you to finish that off right now, and I don't care which method you do, the green method or the red method, and we'll get there. That's too easy. Okay, that's what I got out of that next. Negative 2 times 16 minus x squared plus 2 times the quantity to the 1/2 power plus 6. Did I do that right? I don't feel like I did.
I separated it into 4x, those are square root of 16 minus x squared. There's u, I got 2x.
Okay, so let me chase it that way with the red because the integral of 4x plus the integral of 4x over the square root of 16 minus x squared. And so this becomes 2x squared. That's easy enough. Now for this, we're going to say u is 16 minus x squared. So du is negative 2x dx. But we need 4 there. So we're going to multiply it by negative 2. Really? Negative 2 integral of u to the negative 1/2. Right? So we get negative 2 times u to the 1/2 times 2u to the 1/2. So we get 2x squared minus 4u to the 1/2. Real quick, let me tell you this. Thursday, that's tomorrow. I'm not here for class tomorrow, okay? So you will have all period to work on your FRQs or your WebAssign, which is only 10 problems. The WebAssign is due Thursday night. Friday, I'm going to give you on paper probably about 4 or 5 problems integrating by substitution. You do. That's what we're going to be focusing on, okay? That's going to be an in-class assignment on paper Friday. So the only homework, the only thing to turn in is the WebAssign tomorrow night, the 3 FRQs Friday. We've got that written assignment in class on Friday.
Are Friday's problems going to be similar to those that we just did?
There's probably going to be a mix of all of them. There's going to be some really easy and some like this. If I were you, I'd go back and work the 3 or 4 problems we didn't do, just to kind of get yourself familiar with it,
Okay.
getting ready for Friday.
Thank
Okay?
you.
Thank y'all. Yes, quiz, something like